Hi everyone, welcome to another Tiny Experiments. So for this one we're looking at some tiny experiments you can play around with, and as always I will provide the code on GitHub and a link in the descriptions to get there. But yeah, tiny experiments which help us push the limits of an LLM to spark creativity. Now I'll go through this. It's very sort of simply laid out here. There isn't an awful lot of commenting because it doesn't need it. It's very linear. And then that way you can do all sorts of refactoring fairly easily, vibe code it, whatever you fancy doing with it. But I'll walk through and then I'll sort of point out some changes you might want to make because it's pretty simply put together. So we've got a main function here, run experiment, which takes an experiment number, experiment title, a prompt, which is the most important bit, and then the model name, which is actually just set, and then it's not overridden. It doesn't go in as a attribute when we actually call the function, even though it could do. It just defaults to this particular value, which at the moment is set to llama3.1. As it says here, you will need a llama for this hobby. In addition to a llama and your weak lemon drink, you will need Python, and you will need to have pulled whatever models you fancy using. And you will need to pip install the Ollama library. And obviously with Python, it's up to you what ID you choose. I tend to be leaning a lot into VS Code recently, just because I'm jumping around in a lot of different programming languages. And although in the past I've always mentioned that I do tend to use Spider, which is part of Anaconda, I find because within a single day I might be in Python 1 minute and I'm thinking about dabbling with some Crystal at some point, so I'll be encoding Crystal, and I find that VS Code is really good for doing that if I'm sort of swapping around quite a bit. So hence why a lot more episodes I'm sort of doing in VS Code. Anyway, back to the function. So yeah, there's some side effect stuff here. You can see here from what we've got, it prints within itself. There's no return values outside of that go outside the function. So we've got something that just nicely prints the experiment and then the prompt and then runs the experimental prompt. We're not streaming, we're not doing anything here fancy beyond that. And remember, here we're using local Ollama models. We're not using Google Gemini APIs I've done in previous episodes. This is purely in Ollama with, in this case, llama3.1 and Python. Now, as we go through, you'll notice this is very simply done. So we've just got our main section here. We're just printing out a header at the top, and then we're just running each experiment one after the other, providing it with a number, a title, and the prompt. And the idea here, and why I like to use Ollama particularly to do this, is we're sort of nudging the LLM in weird ways to get some interesting and creative results. So this is all text-based stuff. We're not doing anything here with art or speech or anything like that. But I find it's really interesting to take the smaller models, and of course Ollama helps facilitate that, and to just really sort of push it and try it with one model and then another. So I tend to start off with either Llama 3.1 or Gemma. I mean, currently on my machine, I have these pulled down, and I've cleaned it up a bit because this was getting rather bloated, and I had all manner of different sizes of models that have been distilled. But I've gone back to the sort of core ones I tend to keep using. I think the most recent thing I was dabbling with in Ollama for a future episode was to do with embedding and some RAG stuff. So that's why these are relatively speaking, because since then I've been playing around a lot with Google Gemini and other things. So yeah, that's what these are up the top. I had to sort of re-download these two because I accidentally blew them away. Oh yeah, these two. And at some point in the future, I want to do an episode on code creation using models in Ollama, and I'll probably do DeepSeek R1 and whatever the most recent version of Quen is. They'll run on my machine, so that's something to look forward to in the future. So there will be some more Ollama based episodes. It's just I've not been doing them for a while because I got rather caught up in everything that's been happening in the Google Gemini API. So yeah, we've got this interacting with Ollama. We're leaning into the Ollama library this time rather than just doing it with requests, which we could do. And so it makes things a little bit simpler for us. A little bit of error checking, not a ton. And then we just go through the experiments one after the other. So of course you can play around with these, add them in. The other thing you could do is create a dictionary of experiments and then create a iteration over that dictionary and then run or call the function against each iteration in the dictionary. That would be another probably cleaner way to do it. But this is just a nice linear way, explanation-wise, because you can sort of see the experiment sort of isolated here. So, first experiment, see it from a different view. Imagine you are the oldest, wisest tree in a magical forest. A small bird lands on your branch and asks you for the most important life lesson you have learned. What do you tell it? And so you can see over here, I've already run this because these local large language models on my setup here take a little while to run. So you probably go off and have a sandwich and a beverage while this is running. Experiment 2, constrained creativity. So this is one that I've done before, where you might ask it to write something like a poem about something, and then every line has to end with a word that's also something else. So you can see here, it did a pretty good job. It's got 5 lines: Neptune, Mercury, Jupiter, Venus, Earth. No mention of Pluto, which isn't a planet. Does it say specifically about a planet's name? So that's good. And we move on to logic, abstraction and puzzle solving. So fairly straightforward. We're assuming that somewhere in Llama 3.1, somewhere in its neural network, it knows about the fox, goose and beans river crossing puzzle. So we're asking it to represent that. The steps in a clear numbered fashion. So there we go. Now of course you'd have to check this. I'm not saying here it's got it right, but that's the whole point of this, is just to see how it fares with these things. Constrain creativity, logic and abstraction. 4, coding for the absurd. Write a Python function, takes a string and returns a new string where every vowel is replaced with a random emoji. The function should be well commented and include a simple example usage. And so we have it here. Now notice with this is all getting printed just to the console, to the terminal. You could add in extra code here, and I've done it in the past, to save this to a .md file, something like that, if you wanted to. However you wanted to save it. But for the purpose of this experiment, we're keeping it simple. Everything's on the screen, and it's not overly long, so we're not going to lose anything in the terminal, or it gets sort of pushed out. So here's our solution again. You'd have to test this to see whether it got it right. And this is where it's interesting to play around with different iterations of this with different models. Particularly, you know, if you're going to start pulling the distilled versions of the same model and then just see how they fare as you sort of go down in size. That's quite an interesting thing to do. And to see at what point you get these interesting weird hallucinations as well, which can add to the creativity. The other thing you'll notice here, I'm not playing around with any temperatures or anything like that, so that's something else you could mess about with. Ideation for a fictional product. You're a product designer based on 3 of an innovative I can't even say it today. Innovative. Oh dear. Innovative, there we go. Features for a smart teapot that go beyond just boiling water. For each feature, provide a name and short description of its function and benefit. So we have here smart sleep, taste tracker, and T-Mind. And of course the other thing you could do is you could run the experiments again a second time without changing anything and seeing, you know, on the same model and just seeing, you know, how variable the results are. And that's also where adding in stuff to do with top P and top K and temperature and things like that as well in the requests can create interesting things as well. Historical reimagination. What have we got here? Oh yeah, recount the story of the discovery of electricity, but from the perspective of a squirrel who was accidentally part of Benjamin Franklin's kite experiment. Make it dramatic and a little paranoid. 7. Clarifying complexity. Explain the concept of quantum entanglement to a child who is just learning about magnets. Use simple analogies and avoid complex scientific terms. And you could play around with that with all sorts of weird things. So I don't know, explain the concept of quantum entanglement to a child who has just learnt how to make yogurt. What if scenario? What if humanity's only form of communications was through music? Describe how a complex concept like a legal contract or a scientific discovery would be conveyed. There we go. Metaphorical expression. Create a metaphor to explain how machine learning models learn. Use the analogy, this is interesting to play around with actually, of a chef learning to cook new dishes. Be detailed and descriptive. And then confronting the impossible. What does the number 5 smell like? Be creative, poetic, and don't say it has no smell. So what I also did here is I did do a second run using, on my system, a smaller model. So I used, for a second run, 5.3. And I'm not going to go through in any detail, but there are a few things that sort of stand out. For instance, the wheels fell off of it because although it did mention on several of the lines planets, it didn't do it. It didn't end it that way. I'm not quite sure what happened with the fox, goose and beans river crossing crossing puzzle. I got very confused reading its interpretation. It's interesting now. It was going on about, for safety reasons, the fox cannot be left alone with the goose without supervision. That's an interesting way of wording it. Unguardability issues. Yeah, anyway. Seems to be a lot of backwards and forwards here going on here. I don't even know if it's actually following the rules, but yeah, anyway. The coding of the absurd took an interesting turn. I'm not quite sure what happened here. Anyway. It might have been doing, yeah. It looks like it tried to do sort of thinking mid-flow on there. Again, you know, you'd have to run this, but there's something strange going on here. Got rather convoluted. That doesn't look too contentious. I don't know, I haven't quite read it yet, but anyway, didn't seem to have too much trouble with that. There's a story about Benjamin Franklin and the paranoid squirrel. Oh, it's going into rubber ducks and magic beans and magic balls there. Like special friends that share an invisible bond. Hypothetical reasoning. And then metaphorical expression. There we go. Confronting the impossible. So hopefully that's given you a few ideas for some other experiments that you could do to create create spark creativity, and yeah, maybe let me know in the comments what sort of prompts you tried out, because I know you can't. It's pretty difficult to post on YouTube now, like links to anything. But if there's a particular prompt you thought was amusing, then yeah, and you know, genuinely caused a creativity spark, not just amusing in and of itself, but yeah, did actually cause some creativity flourishing, then I would be very interested. And so, happy experimenting. Thanks once again for watching. Bye for now, and I will catch you in a future video.